Sounds right.
Hello children, welcome back. Nice to see you all. In today's class, let us start with a new topic that is all about vector concept. Before starting with, let us understand the difference between the scalars and vectors with few examples. So here we begin with scalars and vectors. So first of all, let us try to understand what exactly a scalar is. Children, what is a scalar? A physical quantity which has only magnitude. Any physical quantity which has only magnitude but no direction is called as a scalar. Okay. So let me read the definition, children. A physical quantity which has only magnitude and no direction. Best example for this are mass, length, time, temperature, area, volume, density, and many more. So what is a scalar, children? What is a scalar quantity? A physical quantity which has only magnitude and no direction is called as a scalar quantity or simply a scalar. Examples for this are mass, length, time, temperature, area, volume, density, and so on. So how these quantities come under this scalar quantity? For example, if you consider the mass of a sugar, then we say that the sugar weighs 20 kgs. The mass of the sugar is 20 kgs. Do we ever say the direction of the mass of the sugar? Where 20 kgs east, 20 kgs north, up, down. So nothing we will be mentioning. So it is not at all bothered about the based on the direction. Only mass. Only magnitude. So here a scalar quantity has only magnitude. Magnitude means how much it consists of. Okay. So the same will go for the length. So how much the length is. We never indicate the direction while we measure a length. Similarly, for time, temperature, area or volume, we only prescribe how much quantity is there but not in which direction. And always remember that children, these scalars, for these scalars, if you want to add up two different physical quantities, you have all the simple algebraic laws are applicable. That is, the simple addition, subtraction, multiplication and division, normal algebraic rules are applicable while performing the algebraic operations on the scalar quantity. They are directly added or subtracted or multiplied or divided. Okay, so this is all about your scalar quantity. For example, if you consider that whatever we have consider the previous example, 20 kg of sugar. So in this, 20 indicates the magnitude. 20 indicates the magnitude. So how much indicates your magnitude, and kg is nothing but units. How much magnitudes are there? For example, if you represent here kg, it indicates mass. Suppose if you indicate meter, then it tells us all about the length. The same if it is measured in seconds, it tells us about the time. So it all depends. This unit indicates what physical quantity is there and the number indicates how much that quantity is contained. So always remember, simple algebraic rules like addition, subtraction, multiplication and division are applicable for scalars. Now let us discuss in detail regarding the next one, that is all about vectors. Now vectors? Any physical quantity which have both magnitude as well as direction are called as a vectors. I repeat, a physical quantity which has both magnitude as well as direction will come under, are called vector quantities, are simply vectors. Let me write the definition. A physical quantity which have both magnitude as well as direction is called a vector quantity, or simply vectors. Are called vector quantities, or simply vectors. And what are the examples for this? Examples for this are velocity, acceleration, force, momentum, displacement, and so many. So if you talk about a velocity or acceleration of a particular body, then we say that the body, the particular vehicle, let us suppose that the car is moving with 80 km/h towards east. Car is moving with 20 km/h towards east. Here 20 km/h 80 km/h towards east. So this 80 km/h indicates the magnitude, and towards east indicates direction. So if you don't mention direction, then it is meaningless. Similarly, acceleration or force. So is it a pulling force or pushing force, opposing force or supporting force? Everything matters. So how much force is applied? 20 Newton force is applied. Which direction? Forward or backward? The motion of the body changes. When the direction of force, the application of the direction of the force is being changed, the motion of the body also changes. The force can be applied at certain angle. So depending upon the direction of the forces, the body has the tendency to move. So this all, either displacement, velocity, acceleration, force and momentum, all depends upon the direction. Okay, so what makes the difference between a vector and a scalar? As we have told you that the scalars, algebraic method, algebraic laws are valid. But here, the basic algebraic rules are not valid in vectors. That is, the addition, the normal algebraic addition, subtraction, multiplication and division are not valid in vectors. So it depends upon one another factor, that is a vector law of addition. It should satisfy the vector law of addition. This you will be learning in your higher classes. So vector law of addition is totally different as compared to the normal arithmetic operations. Okay, so what exactly makes the difference between a vector and a scalar? A scalar has only magnitude, how much the quantity is present, and we don't bother about the direction. Whereas for vector, we have to discuss regarding how much magnitude is there and towards which direction the body is in motion. Okay, children. So, how a vector is represented. So, whenever if you want to represent a vector is represented by a directed line segment. A directed line segment. If you want to represent, for example, general condition, if it is a car is moving with a velocity of 80 km/h, then the speed of the car is, suppose something like, we'll let it represent it something speed as s, then speed means speed will come under scalars, no direction. But if it happens to be velocity, then the velocity vector, it either be represented by the letter above which an arrowhead, or another way like your textbook or computer language, it can be represented by bold letters or something like this. Whether it's a bold letters or a vector with a directed line segment. These are both the representation of a vectors. This is the general format when we will be copying or writing. And similarly, if you would like to represent the same vector through graphical representation or geometrical representation, okay, so the geometrical representation of the vector will be something different. Geometrical or graphical representation. A vector must have two conditions. One is magnitude, the other is direction. So magnitude, you will be representing it with some number. So that magnitude, when coming to vector, so the length of the line when measured on a proper scale indicates the magnitude. The length of the line indicates the magnitude, whereas the arrowhead indicates its direction. The arrowhead indicates its direction and the length of the line segment indicates its magnitude. So graphical or geometrical representation, this indicates your magnitude and here this indicates your direction. The same thing, if you represent the same in the opposite, the direction of the vector is different. And here the direction of the different will be something like different. So the length of the line segment indicates the magnitude and the arrowhead represents the direction of the vector. Children, so based on that, let us try to apply the knowledge in solving numerical. So let us move to the next worksheet. And before that, if one more example I would like to tell you, children. Suppose a person is taking a path, like let us suppose that a person moves initially from this way. Let this be represented as A to B. So this is the direction the person has taken. So initially the person has moved from A to B and then again from B to C. Okay, so this person has taken a path from A to B and again from B to C. So then what is the position of the body? If you want to represent the path taken by the A, then it is nothing but this must be equals to the path traveled by the person is from A to C. If he is moving from A to B and then B to C, it simply means that he is moving from A to C. So the complete path A to B and B to C is equal to the path taken by him from A to C. So this makes the difference between how a vector as well as a scalar. If you want to scalar means you have to take the total reading. Vector means the directed line segment which joins the initial position to the final position. That's it. It indicates the shortest length.